In this video, we will look at the fundamental trig identities and some verifying and simplifying that typically gets used with them. The identities fall in three categories: the reciprocal identities, the tangent cotangent identities, and the Pythagorean identities. It's probably a good idea in your studies to know where they come from. We're not going to do the derivations in this video. You can probably find that somewhere else in a textbook or a different video, but I'm not going to go through those in this particular case. Just to frame what we're going to do, these identities are primarily used when we simplify and solve trigonometric equations. They allow us to make substitutions and simplify and cancel, reduce down, reduce the number of trig functions, all sorts of things like that. The first category, the reciprocal identities, in the case of my class, we had already gone through these. Cosecant equals 1 over sine of theta, secant of theta excuse me, equals 1 over cosine of theta, and cotangent of theta equals 1 over tangent of theta. In some publications, you might see an additional 3 reciprocal identities to go with it, being sine of theta equals 1 over cosecant of theta, cosine of theta equals 1 over secant of theta, and tangent of theta equals 1 over cotangent of theta. And while that is true, those second set of 3 identities are not really different. They're just, if you take the reciprocal of both sides on the first set, you get the second set. Some publications will list all 6. Some will just list 3 and make the assumption that the other 3 are virtually the same thing. So, but in any case, you want to be able to use the reciprocal identities. The tangent cotangent identities, tangent of theta equals sine theta over cosine theta, and cotangent theta equals cosine theta over sine theta. Really helpful. We really do like to do a lot of work in terms of sine and cosine, more than probably tangent, cotangent, secant, and cosecant. And this gives us a way of replacing tangent and cotangent with sine and cosine. The Pythagorean identities, they're built off of the Pythagorean theorem. The first one, sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. Of those 3, the first is probably the most common and the most used. In your study of trigonometry, you probably want to know all 3 short term. If you're going to further your math work, the first one's probably of the 3 the most important to remember long term. Your work with these identities, all 3 sets of identities, is much easier if you know them. I might make a note card that lists the 8 of them on there. Use it as a bookmark, as a reference while you're doing your homework, while you're doing your problem sets, to help yourself through, so you have something to refer to and look at and look at and look at, and you'll find that eventually you don't have to look at it anymore, that you'll just simply know how to do it. Generally, we use these for a couple of things. One is to write one function in terms of another, so we might say something like express tangent of theta in terms of cosine of theta. And what that statement means is eventually we want, our end result is going to be a mathematical statement, an equation that has tangent of theta isolated on the left-hand side of the equation. And then the right-hand side of the equation, you can involve operations, symbols, values, but the only trig function allowed on that right side is going to be the cosine function. That cosine function can be listed multiple times. It could be under a radical. It could be raised to a power, so on and so forth. But we have to get ourselves to that point. So that's what that's our goal. So what we have to do is start with some sort of identity that gets us going, that uses tangent and cosine or something about that. And what I might start with is something like tangent of theta equals sine of theta over cosine of theta. And that's a pretty good start because I have tangent of theta isolated on the left, I've got a cosine on the right, and I guess my difficulty becomes the sine of theta. How am I going to get rid of that? Well, to do that, I'm going to use a second identity that if I use the sine squared theta plus cosine squared theta equals 1 and rewrite it as sine squared theta equals 1 minus cosine squared theta, and then sine theta equals the square root of 1 minus cosine squared theta. I can then take that statement and put it in for the sine function, since they are equal, that I have above, and I end up with tangent of theta equals the square root of 1 minus cosine squared theta over cosine theta. And that's an example of expressing tangent of theta in terms of cosine of theta. You need to start with some identity. You need to make some simplifications, some substitutions, and get yourself to where you need to be. That one was pretty easy algebraically. They can be more complicated than that, but that's just one quick example. The other style of problem that you typically encounter in these is to verify an identity, to prove, to demonstrate, to show that something is true. For example, you could say, verify that tangent of theta plus cotangent of theta times tangent of theta equals secant squared theta. And sometimes it will say it, but sometimes it doesn't. But the implication is by transforming the left-hand side into the right-hand side. So I don't want to treat the statement like an equation and work with both sides like I'm solving. What I want to do as I work through this task is think of the left side as the question, the right side as the answer, and my job, my task is to fill in the details in between. So I'm going to start with tangent theta plus cotangent theta times tangent theta. And I know at the end I want a secant squared theta. When I look at this, I'm thinking about seeing the distributive property. So I'm going to distribute the tangent theta through the parentheses and have tangent squared theta. And I'm going to have plus 1. Plus 1 because tangent and cotangent are reciprocals, and when you multiply reciprocals, you get a product of 1. And then tangent squared theta plus 1, that is one of our Pythagorean identities, that 1 plus tangent squared theta equals secant squared theta. So I can go here and simply say that equals secant squared theta. Those are a couple of just pretty simple examples. Maybe I'll make a follow-up video with just a couple of more complex examples, but that's just enough to get you going on what you would do with your Pythagorean reciprocal and tangent cotangent identities. I hope you found it helpful, and look for a follow-up with maybe some more complicated examples.